Alright, hello once again. This is Jeff Scott of Rankin Technical College. I've been going over the course technology text, JavaScript 6th edition. We are up to Chapter 11 of 12, which starts in the textbook on page 741 and is entitled Updating Web Pages with Ajax. Remember, Ajax is an acronym that stands for Asynchronous, JavaScript, and XML. So our chapter objectives are shown here. Describe the steps involved in using Ajax to update data, create an HTTP request and interpret an HTTP response, request and receive server data using the XMLHttpRequest object, process data received from a web service and add it to the document object model, or DOM, and finally update data using JSON-P. Okay? So, what we want to talk about in here, as much as anything else, is the fact that let's assume for a second that we have a person has some kind of a form that they're filling out, and it asks for the typical information: your name, your address, city, state, zip. Let's say there's about a dozen fields in it. All right, and let's assume that somehow you fat-fingered, and when they asked you for credit card information, you put in something that was unacceptable. Well, back in the day, what would happen would be you would just go in and you would send that request out to a server. The server would look at it, would realize that you had some kind of a mistake, and it would send it back to you. Well, one thing about people who typically use the internet, and again, this is a generalization, but many times, for lack of better words, they're impatient. And it gets sent back. Well, that's not a bad thing if it gets sent back and there's a dozen fields and 11 of them are still filled out. But the one field that's not filled out is the one where they made a mistake in their credit card number. But if it comes back and they had 11 of 12 fields filled out correctly, and it comes back from the server and now all those fields are blank and they have to fill them out again, they might just throw their hands up in the air in disgust and say it's not even worth it. All right? Well, in much the same way, when you use Ajax, I'm going to give you an example. This is my example of Ajax. I think it is one, and I think it's a true one, but you may or may not agree with it. Okay, so if I go out to familyvideo.com, and on familyvideo.com, I go out to new release rentals right here. All right, and then I think to myself, you know what? I'd really like to see this movie Zootopia. So I take my mouse and I put it over Zootopia, and notice what I get. It doesn't redraw the entire page. Rather, it gives me a little bubble sort of underneath where my mouse is, and it gives me some explanation about the movie and what's in it. When I move off, it goes away, and if I move on to the next movie, I get the same thing. So what I'm getting is what's referred to as a partial page refresh. It's not redrawing the entire page. It's just giving me information where I need information. So Ajax allows, as it says, client web pages to quickly interact and exchange data by using not reloading the entire page, but with using what's typically referred to as a partial page refresh. It's not a new concept. It's actually about 20 years old. All right. It relies on a programming language like JavaScript, and it relies on data being exchanged in a format like either JSON or XML. So back, I believe it was around the early 90s, Microsoft, and let's give Microsoft credit because I'm one of the first to bash it, but let's give it credit that Microsoft had something that existed that was called an XMLHttpRequest object, which was typically shown as an XHR object. And notice what it does. It uses the hypertext transfer protocol to exchange data between a client and a server. It can be used to request and receive data without reloading a page. All right. So for instance, if I was taking a test, and on that test, let's say that the idea was I would keep answering questions until I got every question right. Okay? So let's assume that on the first page there's 20 questions, and I answer all 20. And let's suppose I didn't do badly, so I got 18 of them right. Okay? Well, if the idea is that I got 90% right and 10% wrong, really I probably shouldn't be, what's the word I'm looking for here? What should happen ideally is it should show me the 2 that I got wrong and allow me to change those. I shouldn't have all 20 of those questions go blank again and have me answer where I had 18 of them right to begin with. That's confusing, and it really, when you think about it, is unnecessary, at least in most cases. So, they talk here about combining an XMLHttpRequest with DHTML. Remember, that's an acronym for Dynamic Hypertext Markup Language, which is kind of a combination of HTML, JavaScript, and cascading style sheets to allow for the dynamicity that we've talked about in previous chapters. Notice it allows update and modifications to portions of a page. Google was one of the first in this, and this is Google's suggest. So as it says, if I start typing in solar, it's going to give me a bunch of things in there with solar. And if I'd hit the space bar, for example, the solar movie and the solar city would go away, because that's not a possibility based on what I've keyed in so far. So this is used a lot. Another one where it's used is Google Maps. Before we go on and I show you this stuff, and we will talk about it, that's in your book on 743, let's talk about a couple other things. And I don't even have them up on the screen yet, but I'm going to bring them up right now. All right, the first is there's a gentleman named Jesse James Garrett. All right, and there he is. Okay, there's an about, etc. There's his Wikipedia. But if you look down to here, he's the one who years ago, it was at least 10 years ago, if not longer, wrote an article called Ajax, A New Approach to Web Applications. This kind of was a kickstart to the whole Ajax movement. And it's not a real big article, but he explained in here how Ajax can be used, and he had a little Q&A afterward, all right, as to what Ajax is, how it can be used, why it should be used. So you'll notice again, it's a good 10 to 12 years, almost 12 years old. But I'm going to grab this, goofed up. Yeah. I'm going to grab this though, and I'm going to just drag up. I tend to do this a lot with articles that I like and that I think are important enough for people to use and look at. Okay, so there's all of it's highlighted. I'm going to copy it to the clipboard. I'm going to start up Word. I'm going to paste it into Word. And after it's pasted in, I'm going to go back and I'm going to grab the URL. And I'm going to copy that in as the header for my document. Again, this is just my way of doing things. You may or may not agree with it. And then I'm going to also insert the page number in here. At the bottom of the page, and I like to put it in the right-hand corner. All right, so let's look at what we've got here. So there's page 1. There's the pictures in page 2. How Ajax is different. You know what? I'll just put that on a page there. All right. Like to have that figure 2 up in here, but I'm not sure if I can do that or not, so let's see. That's fine. And let's see, it's going to be fun. There's the Q&A that starts. That's nice where it starts. Let's put that question on the same page. So there's just a little 6-page article on Ajax. All right, so I'm going to grab that and I'm going to save that. I don't normally do this in my handouts, but I'm going to do it there anyway. So let's see. Make a folder here. We'll call the folder Chapter 11. And we'll put the document inside of that folder. Now, if you want even more than what you get in this article, and the article is not big, you can also go out to a site like Wikipedia. All right? And I can type in here Ajax. And sooner or later, it's going to give me back, there you go, programming. And I can go there. Notice what it says. It's a set of web development techniques using many web technologies on the client side to create what are called asynchronous web applications. With Ajax, web applications can send data to and retrieve data from a server asynchronously, in other words, in the background, so that it doesn't interfere with what's going on. Okay? And there's a lot of stuff. There's some history, there's some more pictures, and some other stuff if you're interested in that. I'm not going to copy that. You can take a look at it if you have an interest. So, jumping back then, this picture here, figure 11.2, is shown in your textbook on page 743. And what these are designed to do, this picture right here, and the one we're going to look at in a minute, is to illustrate the differences between a standard HTTP request, which returns an entire web document, and that's what you see right here, between that and Ajax. All right. And with Ajax, as mentioned right here, in the first picture that you see, the client makes a standard HTTP request, which is returned from the server and displayed in the browser. In the second example, the one you see on your screen right now, it illustrates the process that Google uses when a user types solar into that Google suggest. Rather than requesting an entire web page, the XMLHttpRequest object requests only the recommended search items for solar. All right, the server returns the recommended search, and then JavaScript is used to display it in the suggestion list. All right. So what they have you do throughout this chapter is enhance an existing web app for what's called whole spectrum energy solutions. All right. The final version of which is shown in your book on 745, and I guess it's not shown here. All right. On 747 and on our page right here, we talk about some of the limitations of Ajax. Again, when many new things are created for the web, sometimes they get prophesized and people say, oh, this is going to fix everything. No. The way that the web works is things work together. In the same way that for a website, JavaScript works in conjunction with CSS, which works in conjunction with HTML. All right? But everything has its limitations, including Ajax. All right? Notice for Ajax, as it says, data is requested can be located on a third-party server. But not all web servers support this, and especially older browsers don't support this. All right, you can use the server-side script as a proxy to access data from another domain. So again, there's always workarounds. A proxy, when you think about what a proxy is, most people think about it that if you're going to have a vote for something and somebody has stock, if they sign over their proxy to somebody, then what they're saying is the person they sign the proxy over to is going to be able to have their power to vote. So it performs requests for other clients and servers in this case. All right. We have talked in previous chapters of the same origin policy. And the purpose of that policy is to prevent malicious scripts from modifying content. So if I've got one window open, I shouldn't be able to go into another window and be able to modify things. All right. Well, one common usage of this kind of thing is working with web services. And with a web service, it's a data source that's made available on one domain for use on other domains across the web. And I'll give you my story. You may have heard it already, but I'm going to say it again anyway, just in case you have not. And that is literally coming in here and talking about web services. Now, years ago, and it was many years ago, I took a class, and during that class, what we did was a lot of different things. It was really pretty much when Visual Basic.net first became popular. It was in the early 2000s. All right, and what we did was we had an application. And even if you don't know what this stuff means, I think hopefully you can conceptualize it. All right. We had what were called two text boxes. So they were two big boxes. And each box had a button underneath it. The button on the left said English to Spanish, and the button on the right said Spanish to English. The idea was you could run the program, and if you typed into the box on the left, you would type in English. And if you pushed the button below it that said English to Spanish, it would translate what you were saying into Spanish. It wasn't a perfect translation, but you get the idea. Or you could type things in Spanish in the box on the right, click the button below it that said Spanish to English, and then in the text box on the left, it would show you the English interpretation of what you just typed in. Again, it wasn't perfect, but it worked pretty well. Well, the reason I'm telling you this is when we did this program, I don't think any of us had the ability to actually write a translator program. So what we did was we called a web service. It was a data source that was out there on the internet that we were able to use as part of our program. And that kind of is what a web service is. So it's something that someone makes available for other people to use. All right. Typically, it doesn't contain a GUI. You have to make your own or any kind of interface. It provides services and data in response to requests. All right. And what was so cool about that was literally it was just a couple lines of code where we had to hook this stuff up. Now, this can, as mentioned here on the bottom of the slide, this can require a unique identifier, some kind of an application program interface key assigned by the service to each person or organization who wants to access it. Now, with some of these, they're free. And sometimes there's a cost involved. Literally what happens with web services is you've got kind of an online yellow pages. And for those of you too young to know what a yellow pages are, back in the day before we had the internet, or especially before we had mobile phones, if you wanted people to find out about your business, you put it in the yellow pages, which was a phone book that was a yellow background with black text, and that's how people found out about your organization. Well, today there are the equivalent of online yellow pages. So if I want to be able to use a web service, I can literally look it up online. These scripts can be written in PHP. They can be written in other languages as well. All right. When you go in to run Ajax from a web server, as it says, you must open Ajax files from a web server. So even though Ajax, the heart of it, asynchronous JavaScript and XML, the idea is JavaScript is working in conjunction with your web server. You can install server software on any computer. All right, here's a couple of examples. And there's another one, and I'm just going to show it to you because I've mentioned it before. And that is if I go out to what's called ApacheFriends.org. apachefriends.org. And it's going to give me a product that's called XAMPP. All right. And it says that when I use that, I get Apache plus, I didn't know it was MariaDB, PHP, and Perl. In the past, this has always been MySQL. All right. And what it does if you download it is it allows you to use your computer, which is typically the client, but it allows you to use your own computer as both a client and a server. Now that's important when you test. So the good news is you can test everything on your own machine. The bad news is other machines can't have access to what you're working on because now your machine is both a client and a server. So using Ajax to update data, as mentioned here, involves 4 different steps. All right, you instantiate an XML/HTTP request or an XHR object for the browser where the script will run. You use that object to send a request to the server. You receive the response from the server with the data you want, and you process that data and incorporate it into the app. All right, so this is figure 11.6, which is shown on in your book on page 752. These are the general steps that are involved. And you can see 1, 2, 3, 4, just what we talked about before. Now, this figure, which is on page 753 in your book and also on the screen right now as we speak, illustrates the use of Ajax when you add a proxy server to the equation. All right, really before you start to use the XML/HttpRequest object, you need to know a little bit more about HTTP to understand how Ajax exchanges data. All right. We've looked at some of this basic terminology already. A user attempts to access a web page, typically by entering a URL in the browser's address box, or they may click a link from one page to go to another page. But in either case, the browser is making a hypertext transfer protocol request or an HTTP request for the web page. The web server, all right, then gets that information and either by itself or by maybe contacting one or more other servers is going to produce an HTTP response. You know that every web page is identified by a unique URL. And the URL has 2 different parts in it, usually HTTP:, but it could be HTTPS or it could be FTP. All right. And either the domain name, which is usually used, or perhaps an IP address. So the hypertext transfer protocol, as it says in the slide right here, it's a set of rules that define how requests made by a client, how requests are made by a client to a server. And it defines how responses are returned from the server to the client. So the client is the web browser and the server is the web server. The host, as it says, is the computer system being accessed by a remote computer. All right, so really it's the web server that's going to, more or less, that's going to get the initial request. And the nice thing about HTTP is notice it's a joint venture between the W3C, the World Wide Web Consortium, and the IETF, the Internet Engineering Task Force. All right. HTTP version 1.1 is what's in use now, and version 2 is in development. And that's, again, for lack of better words, that's always some of the problem with this stuff, is that the software typically is in front of the agencies that are kind of coordinating the software. So as far as understanding HTTP messages, which you can see on your screen, and it starts on page 754 in your book, the client does the request, the server does the response. The client, as it says, opens a connection to the server, and it submits the request. The web server, if possible, will return a response in a way that the client can understand it. So again, typically it'll return a web page. And again, I do want to make sure you understand what's going on here. So again, in English, what I'm saying, I'm going to close because I've got way too much stuff open here. So what I'm saying is if I type in http://www.rankin.edu, if I type that in, that is me, the browser. And when I hit enter here, I'm making a request to a server that's either located on Rankin's premises or that Rankin has access to. And what it's doing is it's saying, oh, you want the home page for the Rankin site. So it's returning that back, and it's returning that back to me as HTML. So it's returning rankin.edu. All right. Now that may or may not make sense, but again, that's internally what is happening here. All right. When you send information via HTTP, it gets sent in different ways depending on how you're sending it. We've talked about in earlier chapters, in the chapter that we talked about forms, we talked about post and get. When you use get, as mentioned earlier, it's basically passing all that stuff in the query string, which means it's passing it in the URL. When you use post, it's taking the information and, for lack of better words, it's kind of hiding it inside of what are called the HTTP headers. And you can see the headers define information about the request or the response. In HTTP 1.1, as it says, there are 47 headers. There are very generic headers, and there are more specific headers. All right, they give you some examples. If you've never heard of the word cache before, that's C-A-C-H-E, not C-A-S-H, but with cache, basically, it's part of a computer someplace, all right, that will hold, it's like a special part of memory that will hold information for you so that you are able to, so for instance, let's say that I bring up the CNN.com homepage. All right, I bring it up. What typically is going to happen is that that homepage will be cached or basically saved to a part of my memory because the computer thinks that I might want to come back to that page. So what it's going to do is if I suggest it again, the same page, then it typically, what it'll do is it'll bring up that cached version. Now you've got to be very careful about this. Notice it says their caching is a temporary storage for faster access, which is what it is. But what if I, as an example, what if it's the presidential election? Let's assume that it's going to be Clinton versus Trump, and it's election night, and I'm bringing up CNN.com's homepage. If I bring it up at 7 o'clock at night when poll numbers start coming in, the numbers are going to be quite different than if I bring it up even at 7:15, 15 minutes later. So the system has to watch it. It typically, when it does caching, it caches different things, and it has different expiry times for different things that it caches. All right. Again, this stuff that's in here, is it important? Well, let me put it this way, because people ask me questions like this. Is what we're looking at right there important? Well, it's kind of like, it's good if you have a fundamental knowledge of your automobile. Because if something goes wrong, you may or may not be able to fix it yourself. But at least if you take it to someplace and somebody tells you, you know that it's a problem with the muffler, for example. And if somebody comes in and says, oh, your muffler's bad, your tailpipe's bad, your whole exhaust system is bad, and they give you 10 things, you can, if you know something about it, you can kind of look at them and say, you know what, I need a new muffler, I don't need anything else. Well, in much the same way, it's nice to have at least a fundamental understanding of what's going on here. So I've talked about get and I've talked about post with you before. There's some more on each one. Again, with a get, you have a query string, and that's where the information is typically passed. With a post, it's considered to be more security safe because the information is basically included, but it's included in a header or someplace where you can't see it directly. Now, if somebody wants to break into your website and find out information, just because you use post instead of get doesn't mean that they're not going to be successful, but you're making it harder for them. And that's one of the things that you have to worry about, all right, when you are working with all this stuff, is you want to make it as hard for somebody to break into your system as possible. All right. So, Table 11.1, which is shown on the screen here, and also in your book on page 758, shows some common request headers. All right, again, I don't want to read to you, so I'll just leave them up there for a second. And some common body headers are shown on the top of page 760 and also right here in your book. Now, the whole thing that we talked about before is a request and a response mechanism. Well, you may want to check with that HTTP response to make sure that it worked okay. So you can check it as it goes along its way. So if the request is received, you will get some kind of a status code that's in the 100s. If the request is successful, you'll get some kind of a status code within the 200s. If the request cannot be completed for whatever reason, all right, without further action, you'll get a response in the 300s. And if there's some kind of an error, you'll get a response in the 400s. So the point is this. Ideally, you shoot for some kind of response in the 200s, and you try to avoid the 3 and 400s. So here are, and there's 500s too, I guess, and that's on the server side. So as shown here on the top of page 761 in your book, and right on the screen right here, is these are the different response codes that you can get back, and these are not all of them. All right, you may have seen the 404 before. All right, and a lot of times when you get that, you've got a broken link or something like that. In that, what that means is you're trying to click to a file and the web server cannot find the particular file. The response returned from a server can be much more involved than the original request that generated it. The initial request from the client for a web page often results in the server issuing multiple additional requests for whatever it is it has to do. So in figure 11.4 here, which is also shown in your book on page 761, they show some of these common response headers. All right. So again, the idea is there's a lot of stuff that's happening behind the scenes between the time that you go in and you request a web page and you have the web page returned to you. All right, requesting server data, and this starts on 765 in your book. As it says, it's the key to incorporating Ajax. It allows the use of JavaScript and the hypertext transfer protocol to exchange data between the browser and the server. And again, the key components in here are JavaScript and HTTP, but this is working in conjunction with the server, so it's not something that's solely being done on a client. The object methods for The XML HTTP request object are shown here and on the next slide as well. All right. This object, again, is the key to incorporating the functionality. You use the methods and properties of this XML HTTP request or HXR object along with JavaScript, again, to build and send request messages and to receive and process response messages. So the first step here that's being shown on the top of this slide for using Ajax to exchange data is to instantiate or create an XML HTTP request, or again, an XHR object. There's no literal form for doing this. It's just new XML HTTP request paren. Again, this object was originally created by Microsoft specifically to allow a document to request XML data. And over time, things have been added to it to make it do things, maybe, to expand what it can and cannot do. Now, it's mentioned in the third bullet there, most JavaScript programmers use a try-catch statement to try to instantiate the object. So if it doesn't work, you can give the user a message back. When you open and you close these HTTP connections, all right, this is where the biggest bottleneck that you have in loading a web page. All right, so if you talk about something taking a long time to load, that's usually why. So once you create the XML HTTP request object, you again want to be able to reuse it, possibly by caching it. All right, because the program will run faster if you don't have to keep recreating the object all the time. So they show you some code here, and it's also in your book on 768 on how you might want to do this. As far as opening and sending the request, after you instantiate the XML HTTP request object, you use the open method with that object, all right, to specify the request, a get, a post, etc. And they show an example probably on the next, well, maybe they don't, but they show one in your book on page 769. Notice again that open method accepts 3 arguments. Async, which means are you going to do this asynchronously? And when you think about things happening asynchronously, what that means is one thing can be happening and you don't have to wait for it to end before another thing happens. Most human conversation I look at as being synchronous. I talk, you listen. When I'm done talking, I listen, you talk. If we both talked at the same time, we'd probably have a harder time communicating. But with asynchronous communication, again, the idea is I can be doing one thing and something else can be happening in the background. And again, I want to make double sure. I want to see what Wikipedia says about something being asynchronous. So asynchronous, transfer credit, etc. Asynchronous. We'll look at asynchronous I/O and see what it says. All right. Notice it permits other processing to continue before the transmission has finished. So again, it's not like most human conversation. There are several methods that were discussed in here, the abort method, the send method, etc. Notice post requests are more involved, and they are more involved. I don't know why that keeps coming up on my screen, but it does. All right, they are more involved because there's more things happening in the background. As far as receiving or the response XML property here, notice as it says, after you submit a request with the XML HTTP request object, the body in the server response is assigned to the object's response XML or response text properties. These properties contain the HTTP response from an XML object and as a text string. So what you can do when you're processing this stuff is you can process the contents of the response XML property by assigning property values to document nodes. Now, this all comes back to the stuff we've been talking about. And with the nodes, again, we talked about the document object model and its use of nodes. So you have seen this stuff before. So the value of the response text property can be any text string. Usually the content is almost always a JSON or JavaScript object notation string. All right, to work with the contents of a JSON string, you use the parse method, which we have, I believe, talked about in an earlier chapter, to convert the string to an object. You can then access the property values of the object and add them to the DOM as necessary. And again, there's an example of that in the book on pages 776, 777, and beyond. As far as sending and receiving asynchronous requests and responses, again, an asynchronous request allows JavaScript to continue processing while it waits for the server response. To create an asynchronous request, you pass the value of true as the third argument back when we went over that open method a while back. There. So it's the third thing in there, and if we make that true, all right, that's what we're asking for. I'm going to make sure that gets shut. Oh, they shut off. Good. All right. Now, when you start working with this, okay, to retrieve or receive, I should say, a response from an asynchronous request, you use the XMLHttpRequest object's ready state property and ready state change event. The ready state property contains one of three values. 1, which means the HTTP request is uninitialized. 2, which means it's open. 3, which means it's in receiving mode. Or 4, which means it's loaded. All right, so again, in this chapter, they have you go through an example throughout the entire chapter with this whole spectrum energy solution. So you will be doing this throughout the chapter. All right. Synchronous responses are easier to handle. Well, that should make sense because there's something that happens and you stop while it's happening, and then when it's done, then you can do something else. All right? But the drawback, as it says, is the script won't continue processing until all the information has been received. So even though asynchronous can potentially be more problematic, it tends to work in a better way. As it says here, the asynchronous request allows JavaScript to continue processing. And this is all stuff I've mentioned before as far as how this is done. And the final step in implementing this, again, is to add the data provided by a web service to DOM elements on an as-needed basis. So on the bottom of 783 and on the slide that you see right here, okay, they start talking about in here refreshing server data automatically. And it says automatically refresh data obtained from an HTTP server. Well, when the app displays data that changes regularly, it's useful to refresh it often. For instance, if you're working with stock prices, you know, especially with the stuff that happened with the Brexit or whatever they call it. To keep data up to date, you can use the JavaScript timeout method or set interval method, okay? So that if you had, for example, a get stock quote type of thing, you could maybe refresh it every 1 minute or every 2 minutes or whatever you wanted to refresh it as. The Ajax method that was implemented in the examples in the chapter here, they use PHP code. PHP is a server-side programming language They use that on a web server as a way to, they use it kind of as a proxy to access and return content from a different domain. This is widely used. But there are other methods that can be used as well. And those methods include JSON-P, which is JavaScript object notation with padding, and that requests JSON content using a script element rather than an XML, I should say, HTTP request. All right. And another way you can do this is with what's called CORS. And CORS is cross-origin resource sharing. And here the server for a web service sends a special HTTP response header that indicates the response data that may be used in other domains. This is kind of explained here on the top of page 785 in table 11.7 and on the slide that you see right here. So as far as JSON-P goes, again, JavaScript object notation with padding, when developers began looking for ways to work around the problems with same origin policy, they looked at one of the few HTML elements that's not subject to this policy, and that's the script element. A web document can load a script from another domain, and it's left up to the developer to ensure that any script like that that's loaded is from a trusted source. This is shown right here. So you can see the process. You create the script element, you add the script element to the document to initiate the request, you receive callback containing data from the server, and you execute the callback function. So all this information is packaged into the URL specified from the source attribute. Although each web service specifies exactly how to craft the JSON-P URL, it generally consists of two parts: the request information and the callback query string. The request information will include the URL of the service and any necessary parameters. The callback query string will append a keyword and the name of a function in the app to be called to process the data that's returned from the web service. And it's often the word callback. Notice as mentioned here that JSON-P can open up a security hole in a website. It is taking for granted that people who use it know what the heck they're doing. So as mentioned, you should only use JSON-P, JavaScript object notation with padding, from a web service that you trust. As it says also, it exposes its application program interface password to end users. So you should not only use it with a web service you trust, but only with users that you trust. Now, as far as the other mechanism that's here, updating content with CORS, all right, again, notice cross-domain request with an XHR object. JSON-P is a reasonable solution for many things, all right, but developers continued working on a method for enabling cross-domain requests within an XMLHttpRequest request, and the result of this was the CORS specification, which is one part of the new spec known as XMLHttpRequest 2. This enables additional properties, methods, and events to be included with an XMLHttpRequest object. JSON-P, the JavaScript object notation with padding, leverages a gap in the same origin policy, and it relies on sites using the technique for malicious purposes. On the other hand, CORS enables a content provider that wants to share its content to configure its server to convey that permission in its HTTP response to the XMLHttpRequest object. So, one of the heavier chapters in the book, but as mentioned, Ajax allows data exchange with just what's called a partial page refresh. The key player in this is the XMLHttpRequest object, also known as the XHR object. It uses the hypertext transfer protocol to exchange data between a client and a server. When you have problems with things like same origin policy, one way to get around that is to use a proxy. HTTP, the Hypertext Transfer Protocol itself, defines rules for client requests and server responses. The whole key to this, again, though, is this XMLHttpRequest request object. The first step of this is to initiate the object. All right. Use the send method to submit the request to the server. Grab what the server returns as either response XML or response text. Use that along with JavaScript. And then use that in conjunction with either JavaScript object notation padding, which requests JSON using the script element, or cross-origin resource sharing, which is typically referred to as CORS, where the server sends the HTTP response header, indicating data that may be used in other domains. And that's it for this chapter. All right, so all we have left now is Chapter 12, which is an introduction to jQuery. Be back with that soon.